So today we're going to cover chapter 11, section 6. Today we're going to find volume of pyramids. Now, yesterday we did volume of prisms. So the picture I just drew on this slide, this is an example of a square, prism, or a cube. Now, if I were to take a square pyramid, it would actually fit nicely inside of this cube. So let me go ahead and add in a square pyramid in here to show you how we're going to develop this formula for volume of a pyramid. Okay, so let's just imagine that this blue pyramid is inside the cube. So when we go to calculate the formula or the formula for volume of a prism, remember it was area of the base times how tall it is. Now for a pyramid, really what we're doing is we're cutting off part of that cube, and because it doesn't fill the entire cube, so what we're going to add in front of our formula is going to be 1/3, because we're going to be taking part of our volume away from it. So it's still area of the base times the height, but then once we're done, we're going to multiply it by 1/3. But what's even easier to do is after you do the BH, divide your answer by 3. So first we're going to talk about what a regular pyramid is. Remember, the word regular in geometry means that all sides and all angles are the same. So a regular pyramid is just a base that's going to be a regular polygon. So if I'm talking about a quadrilateral pyramid, that regular pyramid would be a square pyramid, because all the sides of the base of my pyramid would be the same when it's a square. If it were a regular triangular pyramid, then that base would be an equilateral triangle. So in these regular pyramids, all the lateral edges are going to be congruent. All the lateral faces are going to be congruent isosceles triangles. And then the altitude or the height of the pyramid is going to meet the base at its center. So again, the altitude is also known as the height. So the lateral faces, those are all the triangles going up the sides of your pyramid. So this slide has the official formula. I know I showed it on the first slide, but the volume of a pyramid is 1/3 the base times the height. Now remember, you can also do capital B, the area of the base times the height, and divide by 3. So after you do the calculation of the area of the base times the height, you can just take your final answer and divide it by 3. So in this particular picture here, my base shape looks like a square, so you would do that area of that square, multiply it by the height, and then multiply it by 1/3 or divide by 3. So here, notice a picture is not given, so if it helps you to give yourself a sketch, definitely do that. So it says a regular square pyramid has a base edge of 6 centimeters and a height of 12 centimeters. Find its volume. Give the exact answer. So I'm going to go ahead and draw my square pyramid. So I draw a triangle first here, then a triangle to the side, and then I'm going to show the little edges here that are behind it. So I put them in as dashed. And then this would be my sort of kind of slanty, but this is my square pyramid. And then it told me that the base edges were all 6 centimeters. So I know all these sides here are congruent. And then it also gave me a height, which is going to be 12 centimeters. So I'm going to go ahead and plug in my information into my formula. So officially, it's 1/3 area of the base times the height. So my base shape is a square. So if they had asked you to calculate the base area ahead of time, that's what the capital B is. You would be doing 6 times 6, and the base area is 36 centimeters squared. Now, if it doesn't ask you to calculate it ahead of time, then just plug in all the numbers. Area of the base would be 6 times 6, and then the height is the 12. You're using your calculator. So again, if you want to do 6 times 6 times 12 and then divide by 3, that works. Final volume here is 144 centimeters cubed. Remember, base area is squared, but volume is cubed. Now, if you weren't using a calculator, then what I would have done is probably divided one of these 6s by 3, and then now multiply what remained. But again, you're using your calculator, so you really don't have to do any kind of simplification. Now you could also write the final answer as cubic centimeters. So either way. So for this one, again, it wants us, all right, this is a typo. Notice they gave us the volume. So what we're finding here is the height of the triangular pyramid. So again, here's my formula. It's the 1/3 area of the base times the height. This is what I'm solving for. So my base shape, notice over here, is a triangle. So my base, the capital B, is 1/2 base times height. Notice this H and this H are different. This is the height of the triangle base. So this will be my base of the triangle. This will be the height of my triangle. And what I'm solving for is the height of the pyramid. So let's fill it in. So it's 1/2, 4 times 3. So the base area, the capital B, is going to be 6 feet squared. So now I can replace the capital B now with that 6. So I'm going to be doing the volume, which they gave me. So I'm going to replace the V with what they gave me, 14, equals 1/3 times the 6, and I don't know the height. That's what I'm solving for. So I'm going to go ahead and take 1/3 of 6. 1/3 times 6 is 2. And then now I just divide 14 by 2. And my height equals 7 feet. Next one, they still want me to find the height again. So my height is here. They gave me the volume. Notice my base shape again is a triangle again. So this could be the base of my triangle, and the 3 is the height of the triangle. So again, I'm doing volume is 1/3 area of the base times how tall it is. So I'm solving for the red H. Okay, so for the capital B, the area of the base, 1/2 base times height. It's a triangle. My base is 6. The height of that little triangle at the base is 3. So 1/2 of 6 times 3, and this is going to be 9 meters squared. That's the capital B. Now they gave me the volume. It's 24. I just calculated the capital B to be 9, and I don't know the height. I'm going to go ahead and multiply 1/3 times 9, and this gives me 3. And now I have to just divide both sides by 3, and my height is equal to 8 meters. Okay, so here's our similar solid question. So again, I can do this just like I did when I did the prism. So what we can do is you can either set it up, find your K value and cube it, or what I think is easier is if you go ahead and set this up. Now you can choose. You can either do A over B or B over A. It doesn't really matter. So if I decide to do the volume of B over the volume of A, I'm going to set that equal to the height. I'm looking for a linear measure of B over the height of pyramid A, but what you need to remember is those linear measures get cubed. So now what I need to do is fill in the numbers I have. I don't know the volume of B, so that's going to be my X. So I'm going to put X over 96. The height of B is 6. The height of A is 8. And then remember, this is going to be cubed. Now, instead of, you're using calculators, so you really don't need to simplify. But if you were not using a calculator, I definitely recommend reducing the fraction first and reduce it to 3/4 by dividing it both by 2. Now I have to cube it. So 3 times 3 times 3 is 27, and 4 times 4 times 4 is 64. And now I'm going to cross multiply. So I'm going to multiply 64 times X, and then 96 times 27. And I get 2,592. Divide both sides by 64. And X is equal to 40.5. Now remember, we said X was the volume of pyramid B. So the volume of pyramid B is 40.5 cubic meters. So meters to the third, or you could write out the word cubic meters. Biggest mistake I'm going to see on the test is people are going to forget to cube the side length, or in this case, the height ratio. So remember, that linear measure that corresponds needs to be cubed. So the last one wants us to find the volume of the composite solid. So a composite solid is usually made up of 2 or more solids. So in this case, the volume of the composite solid is going to be found by finding first the volume of the cube and then the volume of the square pyramid on the top. So I'm going to be finding volume of the cube. You can also think of this as a square prism. And then I'm going to add that to the volume of the square pyramid. So what I'm going to be doing here, remember, prism is just BH, and then the pyramid is 1/3 the base times the height. So let's fill it in. So for here, my base shape is a square. So what I can do here is 6 times 6, and then times the height of that cube would also be 6. So this will give me 216. So notice it's got the same base shape. It's still a square, but I need to divide it by 3 or multiply it by 1/3. So I'm doing 6 times 6 times 6, and then 1/3 of that, and I get 72. Once I go back and add this, I get 288 cubic meters, or you could have just said 288 meters to the third.